Okay, so if question in radioactivity, two pure samples of radioactive nuclides X and Y have the same initial number of atoms. So originally we know that NX node equals NY nodes. You have the same number. We don't know the number, but we still can assume it. Let's say for now it's N. The half-lifetime of X is T half. After a time T, passing a time T equivalent equals to 4 half-lifetime of X. The ratio between the left atoms of X and Y is 1/8. So this is the ratio of the atoms left after this time. So N of X over N of Y. This is the left atoms after passing of time T. So they keep reduced by 50%, 50%, and after half-lifetime, 4 half-lifetimes of X, the ratio becomes 1/8. Okay, so we don't know the actual numbers of the atoms, but we know the ratio. To solve this problem in a very easy way, let's assume that this N is any number. Give it 100, 80, 60, 30, any number. Start with any number. I'll imagine they are 80 as the beginning. And since they are same, so they have the same number of atoms, so any number will be correct. So for X and for Y. For X, we'll start with 80. And we know that the time passed until the ratio becomes 1/8 is equivalent to 4 half-lifetimes of X. That's given in the question itself. So I'll reduce it by 40%. This is the first half-lifetime. The second half-lifetime 20. The third half-lifetime is 10. The fourth half-lifetime reached 5. So this is N of X. This is the number of atoms left in our sample X after 4 half-lifetimes. What is the number of samples, the number of atoms left in sample Y after the same time? We can use here the ratio. So Nx is 5 over Ny equals 1/8. So Ny equals 240. So the number of atoms left after passing time T in sample Y is 40. So let's compare it with the original number, which is 80 in our assumption. So this means that for sample Y, time T is equivalent to 1 half-lifetime of Y. So for sample Y, only reduced by 50% in the same time. So in the same time, sample X reduced 4 times by 50%. So sample Y reduced only by 150%. So comparing both results for X and Y, we can easily see that 1 half-lifetime of Y equivalent to 4 half-lifetimes of X. So the answer here will be D, 4T half. So this is an easy solution just based on the definition of half-lifetimes. I know the trick here is that many people will struggle, or many students will struggle to start it from the 80, this one. You can stuck here and you'll start to find a formula, but actually for this part of radioactivity there is no formula in the data booklet, and what you need to know is the definition of half-lifetime itself.